Hello class and welcome to another video lesson. Today what we have is section 2.4 notes day 3. What we're on here is we are on graphing lines as well as looking at a graph and giving the equation of the line. It's kind of funny, I guess. I believe you guys did this in 8th grade. I know you did it in intermediate algebra, which a lot of you took in 9th grade, maybe some took in 8th grade, so you had it in intermediate algebra. We touched on it in geometry. And now this is our third day of it again in advanced algebra. So as you can see, you've had this several years in a row and many days in those several years. Hopefully that is telling you the importance of this unit. Linear equations, graphs of lines, they are used in everyday life all over the place. And you're going to find that even as we go further and further into our course of advanced algebra A. So we want to, again, hit on this one last day here. What we're going to be talking about is parallel and perpendicular lines. So let's have a little bit of terminology so that we know exactly what we're talking about. When we say parallel lines, we are talking about lines that have the exact same slope. Parallel lines have the same slope. So parallel lines, you learn this in geometry. They are two lines that never ever touch each other. They go for infinity up and to the right and infinity down and to the left, and they never ever cross. And the reason for that is because the slope is the exact same. This slope is a rise of 1, 2, 3 and a run of 1. This slope is 3 over 1. It goes up 3 over 1, up 3 over 1. So as you can see, this continues a 3 over 1 slope forever and ever and ever. And the same thing with this one. We start right here and we go up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Same thing. So because they both have a slope of 3 over 1, they go up 3 and over 1, they will never ever touch each other. I can promise you that. So those are parallel lines. Perpendicular lines have negative let me make sure I know how to spell that, reciprocal, I think, reciprocal. They have opposite reciprocal slopes. So just a reminder what a perpendicular line is. A perpendicular line, they cross once and only once, but it's a special crossing. It is a 90-degree right angle crossing. So you guys did this a lot in geometry when you guys did the Pythagorean theorem. Any right triangle, it had that perpendicular line there. When you guys did squares and rectangles and the diagonals of a rhombus, they all are perpendicular. So we had that a lot in geometry. So what we find here is that they are negative reciprocal slopes. That means that their slopes, one is positive, one is negative, and we also find that their fractions are flip-flopped. So look at this blue line right here. This blue line, its slope is a rise of 1, 2, 3, run of 1. A rise of 3 and a run of 1. So I know for certainty, if that's 90 degrees, that this is going to be a negative 1/3 slope for my red line. Let's check it just to prove that I'm right. It goes through this point and it goes through this point. My slope is down 1 to the right, 1, 2, 3. So my slope is a negative 1/3. So for parallel lines, when they never ever cross, they are the exact same slope. For perpendicular lines, when they cross at this 90-degree angle, we know that the slopes are going to be negative reciprocals. One slope is positive, one slope is negative, and then you just flip-flop the fraction to get the other slope. All right, with that being said, for the next, what do we have? 4 problems maybe? 4 problems here. For these next 4 problems, our directions are this. Write the equation of a line that is parallel and perpendicular to the given line and passes through the given ordered pair. Let's answer all of them in slope-intercept form, standard form, and point-slope form. So this one, we want a line that is parallel to this line, so it never ever touches it. And we want it to go through this point. So I'm just going to draw a very rough estimate. I'm not saying that this is going to be the line in any way, shape, or form, but let's say that this line looks like this. Okay, I don't know if it does, but it probably looks something like it. And we want a parallel line that goes through right 1 up 5. So here is 1, 5. I want the equation of a line that looks like this. It's parallel to it and it goes through this point. So what is this line's name? Let's put it into point slope form, slope intercept form, and standard form. All right, our point slope form is y minus y1 equals m times the quantity x minus x1. So I ask you this question: what is your m? What is your slope? Parallel lines have same slope. So whatever the slope is of this one, it's a negative 1/2. That exact same slope is going to be the slope that is parallel to it. Parallel lines have same slope. So negative 1/2 is going to go there. And then for our point, 5 is going to go here, and 1 is going to go in for our x-coordinate point. So we have this. Y minus my y-coordinate. Y minus 5. That equals my slope, which is a negative 1/2 times the quantity x minus my x-coordinate, which is 1. All right, there's one answer. That is point slope form. Let's change this sucker into slope-intercept form. I'm sure you guys are probably tired of this, but the more practice, the better we get at it. Distribute. Y minus 5, that equals a negative 1/2 x. Negative times negative is a positive, plus a 1/2. And now we're going to change it into slope-intercept form, so we have to add the 5. So we get y equals a negative 1/2 x plus 5 1/2, and 5 1/2, if we make that into improper fractions, is 11/2. So this is my answer in y equals mx plus b form. Y equals a negative 1/2 x plus 11/2. So if we wanted to, we could say there is the name of that line. Y equals a negative 1/2 x plus 11/2. Is that what I said? Plus 11/2. Okay, last thing, let's get this into standard form. I shouldn't say last thing because we have to do this exact same thing for perpendicular lines. But let's do this again for standard form now. So I want to get my x's and y's on the same side. So that means I have to add the 1/2 x. So I have a positive 1/2 x plus a y equals 11/2. And now let's get rid of these gross, ugly fractions. No one likes you fractions, so we're going to multiply by 2. And then a 1/2 times 2 is an x, 1x. 2 times y is 2y, and 2 times 11/2 is 11. There we are, class. All this is for parallel lines. Point slope, slope intercept, standard form, all for parallel lines. Let's do the exact same thing now for perpendicular. Perpendicular. There we are. Okay, so we're going to go back to this. Y minus y1 equals m times the quantity x minus x1. So now, class, if you're kind of envisioning this xy coordinate grid, you want a line that goes through this point still, 1, 5. However, it is perpendicular to this line, which means it forms a 90-degree angle. So I'm just going to approximate this. I'm not saying it's going to be perfect. You want the name of this blue line in 3 forms: standard, slope intercept, and point slope. So what is this blue line's name? Well, we're going to go to y minus the y-coordinate. And the y-coordinate is, once again, this 5. Y minus 5. That equals my m. Now, class, what is going to be my slope of this blue line? Slopes of perpendicular line are negative reciprocal. So whatever the slope is of this line, which it's a negative 1/2, whatever the slope is of that line, I use the negative reciprocal approach to get the slope of the perpendicular line. So it was negative, I'm now going to turn it to positive. It was 1/2, so now it's 2/1. It's a positive 2/1 or a positive 2. There is my perpendicular slope. Y minus 5 equals 2 times the quantity x minus my x coordinate, and my x coordinate is a positive 1. X minus 1. Here is one of your answers. That's your point slope. Let's get slope-intercept form. Y minus 5, that equals 2x minus 2. Y equals 2x plus 3. There, my friends, is your slope-intercept form of the equation. Last thing, we got to get it into standard form. So to get x's and y's on the same side, let's subtract this 2x. A negative 2x plus a y equals a positive 3. One of the rules in standard form is that the coefficient in front of a cannot be negative. So what I have to do is I have to multiply everything by a negative 1, or basically change the signs on every coefficient. So a positive 2x minus a y equals a negative 3. Positive 2x minus y equals a negative 3. So going back up to the top again, this is not necessary for you guys, but it's a little bit further understanding, which is nice. Y equals 2x plus 3. That is the name of this line. Y equals 2x plus 3. So hopefully that gives you a little bit of a visual about what we're doing here. But what I require you on the test class, there's going to be 6 points for these problems because I ask 6 answers of you. Here's 1. Here's 2. Here's 3. 4, 5, 6. All right, your guys' turn. Try the same thing for number 2 and give it your best shot on number 3 as well. Pause the video, give a shot on those 2. There's one trick part on number 3. Let's see if you catch it. But pause the video, try them, and then check your answers with mine after you try them by yourself first, please. All right. So I know for my parallel line, my m is going to be 2. For my perpendicular line, the negative reciprocal is a negative 1/2. So I'm starting to strategize here just to help me out. I know that my point for both of them is going to be a negative 1, positive 2, negative 1, positive 2. So I have all the information that I need now right in front of me. And I'm going to say, my point slope form, y minus the y coordinate equals m times the quantity x minus the x coordinate, x minus a minus 1 is x plus 1. And once again, the reason why my slope is 2, for parallel lines it's the same. For negative reciprocal, it is, or for perpendicular, it's the negative reciprocal, and my slope is 2 right here, y equals mx plus b. M is my slope. Here is one answer. Very good, you're 1/6 done. Onward, y minus 2 equals 2x plus 2. Add the 2 here, add the 2 here. Y equals 2x plus 4. You are 2/6 done. And why say 2/6 when we can say 1/3? We are 1/3 done in y equals 2x. Y equals 2x plus 4, sorry. Last thing, let's get into standard form. A negative 2x plus a y equals a positive 4. Then my coefficient cannot be negative in front of my x, so I have to multiply by a negative 1. A positive 2x minus a y equals a negative 4. There is my standard form of my equation. 2x minus a y equals a negative 4. So those 3 answers for parallel lines. You need to do the exact same thing now for perpendicular. Y minus the y coordinate, which is 2. That equals my m, which my m is no longer a positive 2. It's now a negative 1/2. Negative 1/2 times the quantity x minus the x coordinate, x minus the minus 1, is x plus 1. All right. So now we have y. This is one answer, by the way. You're 4/6, which is 2/3 done. Y minus 2 equals a negative 1/2 x minus a 1/2. And then you have to add 2. So you'd get y equals a negative half x. A negative 1/2 plus 2 is 1 1/2, which is a positive 3/2. Y equals a negative 1/2 x plus 3/2 is your answer for standard form. And now, is your answer for slope-intercept form. Now your standard form, let's add this 1/2 x, a positive 1/2 x plus 1y, that equals 3/2. Fractions be gone by multiplying by 2. And then we would get a positive x, a positive 2y equals a positive 3. And those are your answers for perpendicular. I hope that all made sense. On to number 3. Number 3, x plus 3y equals 6. Class, in order to do this for parallel and perpendicular lines, the slope is crucial. So we need to know what the slope is. In x plus 3y equals 6, you could say, Mr. Berge, what's the slope? And I would look at that and say, I don't know. However, I could say, I can find that out. You find out the slope by putting it into slope-intercept form, which is y equals mx plus b. Solve for y is the key. Get this sucker all by itself. All right? So let's isolate that variable of y. First thing we do is we subtract the x. Minus an x, minus an x. So now we have only 3y on the left, and we have a negative x and a positive 6 on the right. And then we have to divide by 3. Tricky part on this one is you have to divide everything by 3. So make sure you do that to every single term. So y equals a negative 1/3 x plus 2. Now class, the reason why we did that is to find the slope. We don't need to know this. We don't need to know this. We don't need to know this. This right here is our bread and our butter. That is what we needed, that negative 1/3. My slope is a negative 1/3, so for parallel lines, I need this negative 1/3. For parallel lines, we need the slope as being the same, which is a negative 1/3. For perpendicular, we need the negative reciprocal slope. So instead of negative, it's going to be positive. Instead of 1/3, it's 3/1, or a slope of 3. All right, now that we have that, the process is the same on problems number 1 and problems number 2. So we'll do this really quick. Y minus the y coordinate equals m times the quantity x minus the x coordinate. There is answer number 1. Answer number 2, slope-intercept form. If I'm going too fast to your class, be sure to pause the video and catch up. Y minus 3 equals a negative 1/3 x plus 2/3. A negative 1/3 times a negative 2 is a positive 2/3. And then we have to add 3. So y equals a negative 1/3 x. We would have plus 3 2/3, which would make a positive 11/3. This is answer number 2 in y equals mx plus b form. Answer number 3, standard form. Let's get this 1/3 x over here. So adding that 1/3 x plus a y equals 11/3. And lastly, we can't have any fractions. Fractions are no good in standard form. So let's get rid of those denominators of 3 by multiplying by 3. Multiply by the first term, by the second term, and by the third term. A third times 3 is 1x plus 3y equals 11. X plus 3y equals 11. All right, perpendicular. For perpendicular, my slope is 3. So y minus the y coordinate equals m times the quantity x minus the x coordinate. Answer number 1. Let's distribute and solve for y. Y minus 3 equals 3x minus 6. Adding this 3 to get onto this side would be y equals 3x. Oh, sorry. A negative 6 plus 3 is a negative 3. y equals 3x minus 3. There we are. And now we have to get it into standard form, so we have to add this we have to subtract this 3x. A negative 3x minus y equals a negative 3. And now let's change the signs on everything so that my coefficient in front of x is a positive 1. This is answer number 5, by the way, answer 5 of 6. So now we'd have 3x plus a y equals a positive 3. 3x plus y equals 3. All right, just about done here. That's basically the gist of our lesson. Make sure that on our test, when it says have the answers in point slope, slope intercept, and standard form for perpendicular and parallel lines, you need to have 6 answers just like we did on numbers 1, 2, and 3 in our notes for today. All right, this one is quite simple. Y minus 5 equals 0. There is no x coordinate on this one. So if we solve for y here, we get y equals 5. Think about it for a second. I'm going to ask you this question and think about it. Y equals 5. In your brain, what kind of a line do you see? Is it horizontal or is it vertical? Hopefully you say horizontal. Y equals 5 is a line, 1, 2, 3, 4, 5, that looks like this. So class, they want a line that is parallel to this one that goes through a negative 3 and a positive 2. Negative 1, 2, 3, positive 2. They want a parallel line that goes through this one. Well, what's a parallel line going to be to a horizontal line? It's going to be horizontal. Oopsie, that was terrible. Let's try this again. Better. Still not great. So that is my line. And what line is that? Y equals the y coordinate, which is 2. Here is 2 right here. Y equals 2 is that line. And class, that's your answer for all 3 forms. Slope-intercept, standard, point slope, it's all y equals 2. And now, class, they also want a vertical line, they want a perpendicular line that goes through this point. Well, what is the perpendicular line to a horizontal line? It would be completely vertical. And vertical lines have an x equals equation. What x equals point is that? It is negative 1, negative 2, negative 3. X equals a negative 3. That's my answer for all 3 of those perpendicular answers. So y equals 2. The 2 comes from right here. X equals a negative 3 for perpendicular. And that comes from my x coordinate, obviously. All right, last one on our notes for today. Thanks for sticking with me, class. I appreciate your efforts. I guess I don't know for certain if you are giving me effort, but I trust that you are. Are these lines parallel, perpendicular, or are they neither? In order to tell if something is parallel, perpendicular, or neither, what have we been doing all lesson? We said parallel slopes are the same. We said perpendicular slopes are negative reciprocal. So what we need is the slopes. Let's find the slope of both of these. 2x minus 3y equals 9. Just like in problem number 4, if you were saying, Mr. Berge, what's the slope of this line? I would say, I don't know. However, I can find it out. The way I figured out is by putting it into y equals mx plus b form. I'm going to subtract 2x. And I get a negative 3y equals a negative 2x plus 9. Getting y all by itself, let's divide by this negative 3. Divide by negative 3. Divide by negative 3. Y equals a negative divided by negative is a positive 2/3 minus 3. Positive 2/3 x minus 3. So what is my slope of my first line right here? It is a positive 2/3. It comes from right here. Y equals mx plus b. So now in my head I'm starting to strategize. Okay, if my other one is 2/3, bam, it's parallel. If my answer for my slope of my next one is a negative 3/2, bam, it's perpendicular. If it's neither of those two, if it's not 2/3 and it's not the negative 3/2, if it's any other number, any one of the infinite numbers that there are in the world, if it's any one of those, we know it's neither. So there's our strategy. 9x plus 6y equals 12. Mr. Berge, what's the slope of this line? I don't know, but I can find it. Subtract 9x. We get 6y equals a negative 9x plus 12. Lastly, let's get y all by itself. Divide by 6, divide by 6, divide by 6. And my answer is y equals a negative 3/2 x plus 2. So my slope, m equals a negative 3/2. If my slope of my first line is 2/3, and my slope of my second one is a negative 3/2, what is the relationship between these two? Those slopes are negative reciprocals. So we say they are perpendicular. And there is the last video on 2.2 and 2.4.